Hello, welcome back to another episode of Math with Haas. You are watching Precalculus Season 1, Episode 2. We're continuing our investigation of exponential and logarithmic functions. Let's hope we put the fun in function. More bad math puns en route. Alright, so in our first video, we saw that the general formula for exponential functions, y is equal to a plus let's fix that, is equal to a times the quantity of 1 plus r to the t. Now, a lot of time when you see exponential functions, they're actually not introduced in this manner. Instead, what you are given is something more like this. So what is introduced is a term b, which is set equal to 1 plus r. So that makes our exponential function that equal a times b to the t power. Now this equation here is what you'll more typically find. It is more simple, a little bit easier to use than this equation over here. However, both will do the job equally. I will usually use this one since it is a little simpler. So let's go ahead and look at an example now, okay? So suppose we are talking about a deer population, okay? So let's see here. Example. We'll type this out. So suppose a deer population of 80 was introduced into a wildlife area. Now, 6 years later, the population was at 180. Assuming that this population experiences exponential growth, find a model for it. Alright. So, suppose a deer population of 80 was introduced into a wildlife area. 6 years later, the population's at 180. Assuming that this population experiences exponential growth, find a model for it. Alright, so the fact that we're told it's exponential means it has to be this equation, y equals ab to the t. You could also use y equals a times quantity of 1 plus r and quantity to the t. Doesn't matter which. Now, we're given some more information here. So we're told that the deer population was introduced was 80. So this here tells us that when t is equal to 0, y is equal to 80. Or if you want, we could say that y naught is equal to 80. This is a y with a subscript 0. Whenever you see a subscript 0 in math or physics, it always means like initial or starting. Okay, so this is saying that the first y value is 80. So this is important information because we can now actually set up an equation where y naught is equal to 80, and this is a times b to the 0. Okay. Now, when we look at this, well, it doesn't matter what b is. It's to the 0 power. So 80 has to equal a times 1. So this tells us that 80 is equal to a, which we should have already known. I just brain farted there. But we should have known that 80 is equal to a simply because we're told that it was the initial population, so that is a itself. I guess this just verifies what we said before about a being initial population, before as in the last video. Alright, so now we are told that we have 6 years later here, right? 6 years later, 180. So we could say that y subscript 6 is equal to a b to the 6. Hard to tell that's a b, so we'll try fixing that. Maybe. Alright, though that's gonna bother me. Let's fix that now. That looks better. Alright, progress. So, we plug in that 180. 180 is equal to a b to the 6th. Alright. Now, we do know what a is. It is 180 here. So, we can go ahead and start solving. 180 is equal to 80 b to the 6th. Okay. So, now we need to solve. So we can divide out the 80. So 180 over 80. We can simplify our lives a little bit by just crossing out the O's. That has to equal to b to the 6th. So 18/8 equal to b to the 6th. To undo that exponent, we can just take the 6th root on both sides. Alright, so b is equal to 18 over 8 6th root. So if we wanted to find an equation, well, we could simplify that a little bit. 18/8, right? 9/4. So y will equal 80 times 9/4. I'm going to say to the 1/6 power. One thing to keep in mind is so if you have the 6th root of something, that is the same thing as that to the 1/6. Now, if we recall the general formula, it was y equals ab to the t. Well, this right here is our b, and it has to be raised to the t. So we can now use our exponent rule here and multiply the t and the 1/6 together and get y is equal to 80 times 9/4 to the t over 6. Alright, so if you notice, I did not calculate what 9/4 was. I did not calculate what 9/4 to the 1/6 was, though we could certainly have used our calculator here to do that. Instead, I wrote it in this manner because it's more elegant. We avoid decimals, and it will give us a exact equation. If you had use a decimal value, you would have to truncate your value. That means you chop it some portion of it off, because a 6th root of that would not be a nice number. In fact, we can look at that. Let's turn on this calculator. Alright. 9 over 4 is 2.25. Let's raise this to the 1/6. See, not a nice number. Not in terms of writing it out, that is. So we definitely do not want to use that 1.1447 or whatever you round to. You want to use this 9/4 to the 1/6, and this actually looks like a very nice equation. So let's go ahead and box this. This is our answer right here. This is our model for this deer population. Alright. Now, exponential functions are often used for radioactive decay, animal populations. Another important one, though, is compound interest. So bank accounts, financing. So when we consider compound interest, let's go ahead and write this down. Compound interest. Alright. So if we think of a bank account that gives you interest, say it compounded monthly. So let's define what this means, compounded. So that just means that interest is calculated, okay? I forgot to see, calculated, alright. So compound interest, compound means the interest is calculated. You're getting paid from the bank for having your money in the account, so life is good. So when we think about our equation before, we had y was equal to a 1 plus r to the t. What we're going to do is start modifying this to account for compound interest, because the bank can pay you, say, once a month, they can pay you once a day, they can pay you once a week, every other week. There are many ways compound interest, like different amounts interest, can be compounded. To account for that, we want to think of it as a new variable. So we're going to use a big capital A for the amount in our bank account. Okay, so the amount in our bank account, we need to have an initial amount we invest. We're going to have our 1 plus, we'll have our interest rate still. Now our interest rate is going to be spread out across the number of times it's calculated in the bank. So if it's calculated monthly, then the interest is going to be divided by 12 for once every month. If it was daily, it would be divided by 365. I'm just going to use an n here. The n is going to represent however many times interest is calculated in a year. Now, since interest is calculated, it could be, well, if we said monthly, it would have been 12 times a year, right? Or if it was like daily, it'd be 365 times a year. That means our t exponent would need to be multiplied by the number of times our interest is compounded. So this is going to be the equation for compound interest. So compound interest, let's go ahead and break this up. So A is the amount of money, or what your account is valued, right? So that's how much you have. A is your initial investment. R is our interest rate. We'll specify it as APR, annual percentage rate. Alright. N is going to equal the number of times per year interest is calculated or compounded. Interest is compounded. And then T is just good old time. Alright. So let's go ahead and make up something. Example. Alright, we'll type this out again. Suppose you invest, how about $3,500 into a bank account at, we'll be generous, we'll pay 2% at 2% interest, compounded monthly for, and you leave it in your account, say, how about 6 years? Oops, how much is your account worth? Alright, so our equation is A is equal to lowercase a 1 plus r over n to the nt power. So let's start noting things. So 3,500, that's our A, so there's 3,500. 1 plus, that doesn't change. We have 2%. Now the most common mistake I see students do is be put in a 2 right here, or a 0.2. 2% is equal to 0.02. Remember that 0.02 is 2%, not any other thing. Otherwise, you will be given millions and millions to your customers, and that is how you run a bank into the ground. Can't do that. As much as we would like that. I would like millions and millions. Alright, so we're told this is compounded monthly. So what this means is that every month interest is calculated, and since we want to figure out how many times a year that is, well, there's 12 months in a year, so that means n must equal 12. So there's a 12 there. Let's close our parentheses, put a 12 here, and we're told this has to go in. We're told that we're leaving our money in there for 6 years, so there's our 6 right here. Now at this point, we are good to go for plugging it all into our calculator. So here's our calculator. So 3,500 times parentheses 1 plus 0.02 divided by 12 to the 12 times 6. So it looks like you'll make about $445. Alright. So this is going to equal 3945. Then the question is, how many decimal places do you go? You would be surprised what students do. 5 decimal places, 3 decimal places. Come on, how many decimal places do you get for money? 2. Unless you go to the gas station, of course, because they get you with that 9/10 of a penny every time. Alright, so this is how much this account is worth. $3,945.84. Alright. Now, let's go ahead and talk about n a little bit more. So, n continued. So, if you're told that interest is compounded, we'll make a nice table here, compounded annually, semi-annually, let's see here, ooh, quarterly, that's a good one, quarterly, well, oh yeah, we're missing monthly, we could do bi-monthly too, I forgot about that one, bi-monthly, bi-weekly, weekly, and we'll just do daily. So here's what n will equal. Nice table. So number times compounded. If interest is compounded annually, that means once a year. So that's 1. Semi-annually. To understand this, we must understand what does semi do for the word. Semi means 2. If you think semicircle, you're like cutting a circle in half. So semi would be like cutting a year in half. So 2 halves of a year. Quarterly. Well, it's like a quarter. There are 4 quarters to a dollar. It must be 4 portions to a year. Or you think every 3 months. So that's a 4. Monthly, there's 12 months a year. Bi-monthly, now this is a tricky one. Bi-monthly says every 2 months. This BI here means 2, so every 2 months. Well, 12 months. We have 12 months total, but now we're only being paid every other month. So we have to take that and divide by 2. So that's 6. Bi-weekly. How many weeks are in a year? 52. So we can answer the next one. That's 52. So bi-weekly is just like bi-monthly. So every other week. So that is 26. And then daily, 365. Alright. Those are some possibilities that n can equal. Alright. Well, if you have enjoyed this video, thank you for watching. Please subscribe to my channel here. Check out the Patreon page. Please support us there. and we will continue our investigation. Join our math party next time.